Hello, everyone. We are really happy to have you all here to another Datarisk Meetup. Datarisk is a technology company founded in 2017, and we are specialized in using machine learning to solve all the problems that we can see in the industry right now. Datarisk was founded by three friends that worked in a bank in Brazil and had a lot of experience in doing models and machine learning models to the for financial companies. And since that, we are developing a lot of products to solve a lot of problems that we can see in the industry. Our idea is to give you tools that are secure, scalable, and easy to use, even if someone that doesn't understand of data science, mathematics, and engineer can operate. Right now, we are specialized in solving problems like demand planning, fraud detection, and create risk models and things like that. Our model, we have a lot of different kinds of ways to work in the company. We can give access to our features like software as a service, but also as with our outsourcing team. So we have a lot of different ways to work on companies. Today we are really glad to have Alessandro Palmas here, that he will talk about DIAMBRA, reinforcement learning, video games, and AI competitions. So thank you very much to participate in our meetup, Alessandro, and you can start now.
Thank you, Bruno. Thank you very much for, first of all, for the invitation and also for this introduction. So let me share my screen so that I can share with you the presentation we have for today. Okay, are you able to see everything? I think so. Perfect. So yeah, first of all, before getting started, let me introduce myself. So my name is Alessandro Palmas. I'm an Italian aerospace engineer that is, really in love with many different complex software applications. And it has been a while now, more than 5 years in which I deep dived into the machine learning world with a specific interest in reinforcement learning. So yeah, today we are going to talk about reinforcement learning, and in order to give you an idea, I prepared a few slides in order to explain what it's all about. Before having a grasp of it, usually when you first encounter reinforcement learning, well, it is when you're approaching machine learning and you find a typical, categorization of different fields of machine learning, like in unsupervised learning, supervised learning, and reinforcement learning. And this is a typical grouping of different machine learning techniques and problems. Well, let me say that instead of seeing reinforcement learning as something, apart from unsupervised and supervised learning, I would say that reinforcement learning encloses them in some sense, because as you will see, when you have to deal with it, you need to be familiar with those techniques like unsupervised and supervised problems. And so you have to be familiar with, especially when you're dealing with deep reinforcement learning, that is basically a merge between reinforcement learning and deep learning. Well, you have to be familiar with things like convolutional neural networks, fully connected ones. And so in some sense, you also gain experiences in those technologies that usually are the basis to approach supervised and unsupervised problems. So usually reinforcement learning is described as a technique that allows you to create autonomous agents, so agents that are able to learn optimal behavior when facing a specific task. This task is usually implemented inside what is called an environment, and the agent needs to learn how to solve that specific task in order to optimize a specific goal. In some sense, a specific performance measure. So think about, for example, since we are talking about finance, when you are facing a trading problem, you want maybe your agent to find an optimal strategy so that by selling and buying stocks, you maximize your gain in this regard. So that measure, so the gain you are able to achieve, is what you are going to optimize. And at the end, what you are looking for is what we call a policy that basically is something that, given your inputs, tells you your agent receives these inputs and decides what action to take. So this is the policy, something that links inputs to actions. Now let's see it in these slides as schema that is pretty standard. So as I said, you have on one side your AI agent, and on the other side the environment that basically embeds what the task is. Now the agent interacts with the environment, sending actions. So as said during the introduction, today we are going to talk about video games. There is a specific reason for that. We are going to see that in a moment. And so in the case of games, your actions are, for example, you can thought about that as a button pressed of a gamepad. So your agent sends actions to the environment using pressing these buttons, and the environment returns two things: the state and the reward. Well, the state is basically, when we play video games, is you can think about the state as the screen you are seeing, so the frame, the pixels that you are seeing, and the reward is more or less the score. Okay, so this is the typical way of interacting between the agent and the environment. Okay, on one side you send actions and you receive in return the state of the game and the reward. Now reinforcement learning aims at maximizing this reward you receive. Okay, so the agent will have the goal of finding a good policy, a policy that, given a state, so given a frame, decides what is the next action, the next good action that will gives you a very good score, so increasing your reward. This is the problem. Now, this is a very simple scheme. This is a slightly more complex one, and is basically the same, but with additional aspects. So as you can see, in typical probabilistic approaches, of course, you have a confidence when you that defines which action you should choose among those available, and the more confident you are, the higher probability you are going to select that specific action, and you send that to the environment that it responds with the state that is, of course, a sequence of frames. But for example, in the case of fighting games, the state of the game is also represented by previous actions you took, because this is very important in case you want to perform combos. So the next action you are going to select depends also on your previous actions. Then the health values of your character, as well as the opponent one, the character that you are using, the character that is on the opponent's side. So all these aspects are part of the state. And of course, you also have the reward. That is, as you can see here, can be, an immediate reward, so basically related to the very last actions you took, or the cumulative one that basically accounts for the entire episode, so for the entire run, and it is what we are gonna optimize in the end. So this is what we are looking for. So we are looking for something that, provided the game state that here you see is basically represented by a set of frames and some additional info like previous actions, health values, stage number you reached. And given these inputs, this policy will decide which actions you need to take, okay, in order to obtain an optimal behavior. Now, this problem statement is a general problem statement, and also solutions can be of different type. You can have very different techniques you can use to approach this field. Well, if you couple reinforcement learning with deep learning, well, in that case, you will be looking for a policy that is something, for example, that can be built by the usage of neural nets, for example. And in that case, as you can see here, well, you can think about processing your frames with a convolutional neural network. Then you can process your additional info with a fully connected one. Then you extract features from these inputs, and you can concatenate them, and again use these features as inputs for an additional fully connected neural net that will then at the end provide the action of choice. This is basically a very simple, example of a deep reinforcement learning approach. In this specific case, this structure you see on screen is the one that I trained in order to, obtain a very good player in different fighting games like Dead or Alive, Street Fighter. Now Tekken is ongoing, training is ongoing for it. But in general, it's a very, very state of the art, let's say, a very cool approach that is at the moment state of the art in the field of deep reinforcement learning. Now, putting these things together, video games, reinforcement learning as state of the art, is where DIAMBRA lives. So we created DIAMBRA, but now it's more or less 8 months. Everything started, we launched it on last November. And it's basically, you can think about it as an ecosystem where you can watch deep reinforcement learning agents, being built, trained, and then, executed on these games. As you can see, this is our website, is diambra.artificialtwin.com. You can, take a look at it right away, and you will find out that we have, for example, a Twitch channel where we stream twice a week, and we stream from, many different things on this field. For example, we coded together agents, we trained them, and we evaluated them running live these agents in order to see how they improved after a batch of training. So it's pretty, it allows you to have a very deep understanding of what is happening behind the curtains of this field. So, and of course, apart from our Twitch channel that you can definitely reach from our website, in the top bar you have all links to it. We also have our own environment. In fact, we created an interface with very famous classic video games. As I said, Dead or Alive, Street Fighter, Mortal Kombat, Tekken, and many more to come. We are building great stuff. We are gonna release everything soon. And of course, there is something already available. In fact, we released the first game and is there on GitHub. Everyone can have it. You can reach the GitHub page from the website. You can download the environment and get started pretty easily. You know, in the repository, you will find examples on how to run this environment, and also Python notebooks explaining how to train a state-of-the-art reinforcement learning agent on it. In fact, you know, this is in what you're seeing here in the screen is the GitHub page. It has a very simple installation procedure, everything explained in the README, examples, and just to give you an idea on how simple it is to interact with it, you know, this is everything you need to know. It's just a 60-line script, and in it contains everything you need to know to get started. So basically, in order to give you a very, very quick overview of what it's all about. So in the very first part, you have standard imports. Okay, so you import here the environment and the models you need. Then you set up everything, like you specify the game ID, you specify where your ROMs are placed. Then you, for example, specify if you want to play as player 1, player 2, 2 players games, these kind of things. Then you specify, for example, the difficulty of the game. In Dead or Alive, for example, you have 4 different difficulty levels. In Street Fighter, we do have 8, these kind of things. Then you select your character and the outfit. So this is basically just settings about the game. And then finally, you interact with it. As you can see, it's pretty easy. Now I have a zoom here. As you can see, the first 2 lines, you name the environment, you instantiate it, then pretty easily you reset the environment, and then you start your loop. The loop is very simple. You select your actions. In this case, as you can see, we are just random sampling the action space. So it means we are selecting actions at random from those available. And once you select the action, you just send the action to the environment. As you can see in the next row, you see environment env.step actions. This is how you step the environment, send in the actions, and you obtain the observation, so basically the frame, the reward, and the done condition. So the done condition, it tells you when you reach the end of the episode, either because you're dead, because your opponent killed you, or because you completed the game. So it's very easy. As you can see, the interaction is super straightforward, and it is implemented following the very famous so-called OpenAI GYM standard. Okay, that's a standard for reinforcement learning. Is the way in which you usually interact with these tasks, with these reinforcement learning tasks. So it's pretty easy to get started, and this is also the environment that we used in our AI tournament, because we 2 months ago we launched our first AI tournament. It was sponsored by Reinforcement Learning Zurich, so an interesting community of reinforcement learning people in Switzerland. And that tournament is gonna end right today, and so it lasted 2.5 months, and people were they were submitting their agents trained on this Dead or Alive game, and they were competing for the money prize. So this was the very first AI tournament we wanted to have, and many more will come in the coming months. We are about to release great news about that, and we're going to have additional tournaments very soon with these environments. So now you of course heard about AlphaGo. This and those that will be on the next slides they were the first very important achievement obtained by reinforcement learning in the field of creating human level agents in games. So AlphaGo by DeepMind was a great milestone in this field. That the greatest thing about it, I think, can be almost agreed by everyone. That is the fact that by these techniques, the algorithm was able to discover, just by playing against himself, winning strategies that were not known by anyone in the field, any expert in the field of this game. And then after AlphaGo, another great milestone, actually the one that inspired me to build DIAMBRA, is the one achieved by OpenAI. OpenAI, what you are seeing here is a screenshot by about OpenAI 5. They trained an reinforcement learning algorithm and to play Dota 2. Dota 2, that I'm not an expert of the game, but they were able to train this algorithm that was able to control 5 different characters at the same time, and they were able to beat the world champions of Dota 2 in this game that is incredibly complex to master. It's a very complex game because you have to you have many different actions you can choose from. The so-called observation space, so the basically the observation space is what describes the game state in a specific moment, is so huge. And so it's a very complex problem, and they were able to solve it just by using deep reinforcement learning. Of course, DeepMind then also was able to apply the same approach on the StarCraft, and they were able to play it at human level or superhuman level, I think. And so a very huge important milestones in this field. Now, before moving to typical industrial applications, again in the world of video games, let me pause for a while and explain you why we often encounter video games in this field. Well, the fact is that reinforcement learning requires a lot of a very high number of interactions between your agent that is undergoing training and the environment. And so on one side, at the very beginning of training, your agent is pretty dumb, let me say. Is performing random actions and is just doing something at random. And so it's very unsafe to deploy it in the real world. So think about driving a car or flying a drone. It could be very dangerous and also very costly. But in video games, you can easily experiment safely these techniques, and this is one reason. Well, the other one is, in video games you can first of all parallelize execution, and so you can run multiple algorithms in parallel, or multiple instances of the algorithm in parallel, in order to speed up the experience you collect. And this is definitely very important because you need a lot of experience in order to improve. And also, of course, it's safer to use it in a simulation, and the virtual version of your environment is the very same one as the real one. So if want to approach the self-driving cars with reinforcement learning, you need to build a simulator where to run your car. Then you need to learn here and transfer what you learn in the real world, because the real world and the virtual world, they are different. This transfer learning is not super simple. With video games, instead, the real world and the virtual world, well, they are the same, because video games are virtual by definition. So this is the reason, these are the main reasons why reinforcement learning is most of the times applied in video games, and is also collecting a lot of success in it. Now, is of course one field of research that is very new. If you think about it, OpenAI 5 was trained more or less 3 years ago, just 3 years ago. So it's pretty fresh, but at the same time, there are a lot of applications that are starting to use it. And here, for example, this is a paper. I believe it was from Ubisoft, the game company, that is studying how to apply reinforcement learning to video games, in particular on multiplayer games, in order to substitute people that disconnect from multiplayers during an episode, a game. And so in order to avoid people dropping out from the servers, they just substitute those that are leaving with AI trained with reinforcement learning. For example, well, in a more, let me say, industrial, in the real world application, well, reinforcement learning is of course also applied in many different fields. In this case, for example, it is used to train a controller to execute acrobatic maneuvers with mini drones. So we could say that is, reinforcement learning is starting to show its huge potential, and they're starting to investigate how to apply it in real world cases. Okay. Now you cannot read this one, I think, but I will summarize what is written here, and also that we have in the next slides. So basically, this is a collection of data about Dota 2. Okay, numbers here are really, impressive. So Dota 2 is a very complex game, the one that OpenAI 5 was able to solve. Well, think about the fact that, for example, in each moment of the game, you have about 1,000 valid actions you can choose from. And this is just enormous. As for the observation space, I believe you have like 20,000 different floating point numbers that represent game situations. So you have huge observation space, a huge action space, and you have to learn how to find the optimal policy. Well, they used an impressive infrastructure to do that. Like, they used 128,000 CPUs coupled with 256 P100 GPUs. And basically, the experience they collected is about 180 years per day of playing. Okay, so in every day of training, they were collecting like 180 years of experience. So this is, it gives you the idea of how this game was complex, and at the same time, how these techniques, they still need to improve in order to be effective, because they needed 8 months of this level of training in order to reach that level. Okay, still, this is the infrastructure schema, and so it's it's very interesting to take a look at, because it shows you how they distributed the training among different servers and how they used sampling from previous models. So it's pretty interesting. You find every single info about this in OpenAI blog. Definitely worth to look at. Now, the point is, they used the very same algorithm that I used to train the model on, for example, Dead or Alive or Street Fighter. Okay, so they were using the very same approach. Of course, you know, since the problem is way more complex, I easily trained, let me say easily, even if it wasn't so easy, on my workstation. That is pretty standard. Is just an i5 CPU with NVIDIA 1050 with 4 gigabytes of RAM. And you know, but the algorithm was the very same. We are talking about the proximal policy optimization that is currently state of the art for end-to-end deep reinforcement learning. And it took me to train the algorithm. I'm gonna show you now. It took me about, I believe it was like 2 months, 24/7. So basically every day at every hour for 2 months, the algorithm was training on this workstation. But you know, results were pretty good and also fancy to watch. So I'm gonna stop now the presentation and I'm gonna share with you my screen and run the trained algorithm on Street Fighter. So as you may know, you know, performances for reinforcement learning, well, they are pretty variable, let me say. So I'm not sure we are gonna be able to complete the game, but hopefully we are gonna have a good reward during the gameplay. So keep in mind that what we are optimizing here is the total cumulative reward that you will be watching on screen. And so, you know, that's our total cumulative reward is our optimization function. So that is what we are optimizing. So everything is starting up. Just a sec. We are loading the environment. We are loading the model. So it takes a while, but we're gonna get to it. This agent, it has been trained to use Ryu. Okay. So he only knows how to use Ryu. It's not optimal for other characters, and that's it. So let's start. There are 10 different, oh, sorry about that. There are 10 different stages. So let's see how it goes. Okay. So as you can see, and now, Bruno, if you want, you are more than welcome to ask question or interrupt me. So you can see here Ryu, and on the left, you can see actions selected by the environment. By the agent. So as you can see, the first round was a perfect. Not bad, let me say. As you will see, we will not be using super moves. And this is, you know, because of many different reasons, but it appears that the agent was able to learn how to play the game without using super moves. And that is a good feature. And yeah, so we just completed the first stage and we are moving to the second one. So this stuff is what we usually stream on Twitch. You know, again, we already went through the other live. We were able to complete that. We were able to complete Street Fighter, and now we are training the algorithm on Tekken. So let's now focus on this one. As you can see, the agent is playing pretty well. Again, a perfect. As you can see, this algorithm has been trained for 210 million steps. Okay, that is about more or less 2 months of 24/7 training. Yeah, that's it. And this is how the system is behaving. Now, believe me, especially the final boss is super complex, and it has not been so easy to obtain a good algorithm. As you can see, the score on the left is 7.39. And so keep in mind that every round, if you obtain a perfect, equals to 2 in terms of reward. And so that's, you know, for reference, in order to understand what's the value of the score, how it compares if it is good enough or not. Now, this is, I believe, is stage 3 or 4. I already lost this count.
I think it's 3. It's 3 right
yeah,
now.
it's 3. Yes. Thank you, Bruno. So you're paying great attention.
I would say, Alessandro, your camera, I think now it's closed. I don't know if you could
okay,
share.
Let me try, because I just, okay. Perfect.
Okay, perfect. We have some interesting questions here. So,
okay.
The first one, I think that everyone was thinking when you said that you took 2 months to run the model, is what's the configuration of your computer right now? So what did you need to achieve this model?
Yeah, thank you. This is a very interesting question. Let me say that, first of all, this model, it took, that number of days, but it also, it is important to keep in mind that for this model, I used a frame size of 256 times 256 pixels in grayscale, a stack of 6. So basically, I'm using the last 6 frames stuck together, and of sides 256 times 256. Now this means that the number, the number of parameters used to train this model is higher than what you need if you use a smaller frame. In fact, if you move from 256 to 128, well, this reduces a lot the number of training steps you need for the very same level of performance. Okay, this is important to keep in mind. This was my very first test, and so I opted for a larger frame because I thought that it was needed this large. But then experimenting around, I found out that also 128 was enough. Now with this 256, I'm using just an i5 CPU, is dated back like 4 years ago, so it's not super new. It's also pretty standard. I was able, I also have like 16 gigabytes of RAM and an NVIDIA 1050. Now, keep in mind that the bottleneck in this case, as usual, is for, it depends on your implementation, on your model implementation, but the bottleneck is usually how to collect experience and not the GPU. So the real bottleneck is how fast you are able to run your environment, maybe in parallel, in order to collect a lot of experience and then send this experience to the GPU in order to train your network. So, at the end, just to give you an idea, in order to train a very good model on Dead or Alive, it took me 1.5 months. But then, reducing the observation space, we made it available for the AI tournament, and people, well, they just needed like 10 days to train a very good model on it. So, it is definitely accessible to everyone, because if you use a small observation space with small frames like 128 instead of 256 pixels, well, you are able to achieve very good performances very easily and very fast. So it is definitely achievable, something achievable by everyone having a more or less pretty standard workstation.
No, really cool. You said that if we get a smaller number of features, and we have a smaller dimension, then we can train this with much less time, and that is connected to another question here by Rodrigo that I think it's really interesting too. Is how do modern reinforcement learning algorithms deals with this kind of problem, high dimensional state space and action space? So what do you see right now, this kind of thing?
Yes, Thank you for the question. Oh, that's a super move. Yeah, the question is really interesting. You know, let me just go back a little bit, because the point is reinforcement learning, standard reinforcement learning is, you know, something that you can approach. Okay, we lost the first round here. Not sure if we are, you know, Hugo is one of those problematic characters in general, but maybe one round, we lost one round and is enough. Let's see. So yeah, the reinforcement learning in general is something that can be approached like with the standard techniques, like the temporal difference, like Monte Carlo methods, like dynamic programming, these kind of things. But when it comes to very huge observation and action spaces, well, you need to approximate things, you know, and you need to approximate things like using deep learning models. That's the real value in using deep learning, and so deep reinforcement learning comes into place. And well, for example, in this case, we have in some sense a huge observation space, because we have frames, and so frames, you know, they have pixels with 255 values each, and so definitely it's complex. The action space is not so big, because of course, you know, we have move actions and attack actions. So let me say arrows on the left of the gamepad, and then buttons on the right, like punches and kicks. But you know, this is smaller with respect to standard, to other problems. So in this case, we have, I believe, like 16 actions, so not so much, and not a big, super big action space. And so that's maybe a smaller problem if compared with the observation space that is higher. Well, in that case, what we did, oh God, that's it. We lost this round. Goki is a very complex character to face, but still, you know, let's see how it goes in the final round. Well, in that case, you know, we were using a convolutional neural net to process frames, to extract a given number of features. In our case, it was 500 features. Yes, we beat him, and we coupled it together with a fully connected network to process additional info like previous actions, health values, this kind of stuff. So you have to reduce dimensionality by leveraging machine learning models, like deep learning models, like convolutional neural nets, and extracting features like that. Okay, it's definitely important. Now, this is an end-to-end approach, and definitely, you know, it could leverage this kind of stuff. Of course, also adopting unsupervised learning, like creating abstraction and world models about your environment, is definitely very important in order to reduce dimensionality and these kind of things. Of course, it's, you know, it's a problem that still has to be solved in the general sense, because reinforcement learning, it needs a very high number of interactions between the agent and the environment, and so it's the so-called sample complexity is still very high, and that is one of the most important directions to test, you know, to improve these agents. Now, just a quick note. We just completed this second last stage. We are moving to the final boss now. Now, let me warn you, the final boss is gonna be super complex. This, as super moves, you know, it's a great thing that we reached the final stage. We, as you can see, the very high score, 28.51. It's great. Now, this super boss, it's really complex. Let's see if we are able to complete the game or not. But you will see there is a different technique. In this case, you will see Ryu waiting for the opponent to approach instead of attacking it. This clearly shows how the approach was, you know, cool and promising, meaning it learned just by itself how to approach in a different way, different characters, and it's definitely impressive. I didn't code a single team. I didn't code a single team about this game. Everything has been learned by moving from the random agent. It's just incredible. Now, oh God, nice. You see, that was a super move, but we were able to kill him nevertheless, and that was key in this case. Now it seems we are in a very good position now, because we won the first round. He already emptied its bar for the super move, and so we are in a good spot. But still, it's all but easy. It's all but easy, and as you can see here, now we are losing this round. But let's wait. Okay, now I believe we are almost done. Yeah, super move here. Okay, neutralized. Not bad. Not bad. Let's see. Oh God. Okay, now this is done. We have a final round. In that case, if we won the last one, we're gonna, finish the game in live. That's always a good thing. But if you have other questions, don't worry. Bruno, don't hesitate. Please ask.
Oh, no problem. I think that everyone is waiting for this last round. Then
let's see. Okay. Okay, now we are okay, now it's done. Come on, guys. Okay, completed the game, guys. So I was doing. Oh no, that's the resurrection. That's a super move. I was talking too soon. That's the super move by Jill. It has this resurrection. Basically, you have to beat him twice in a round. Let's see. Oh, come on. A final hit. A final hit, Ryu. Oh, God. Oh, yes. Guys, we did it. We completed this game in live at the very first approach. You see the score is 30.2. And, this agent was basically a random agent that learned everything, how to play without any kind of human intervention, just interacting with the environment and learning what was the optimal way to approach the contender. Now I can stop it. Okay, this is just the end of the game. And yeah, great. So I'm really happy. I was able to show you how this thing works. Now let me just maybe it could be useful. I will share. This is the architecture of the network you just saw. So basically, you see, we have a stack of frames that is 256 times 256 times 6. So 6 frames stacked together of 256 square pixels. And we have 161 additional info, like side, if you're on the left or on the right, your health values, previous action, and so on. These two things, they go inside a convolutional on the upper part and a fully connected on the bottom part. And the convolutional outputs 512 and the fully connected 64 values. We concatenate them together and we provide them as inputs to the final fully connected layer that gives you the action that you need to execute. This is the architecture of the network. And guys, everything is available on our GitHub, because if you just go on our website, you click on GitHub, and in those examples, stable baselines, this is the AI agent that you can just leverage directly. Everything is right here, together with the policy, and that is the architecture of the network. You can take a look at it, and you can watch it and getting familiar with how it works. Yeah.
No, it was really impressive.
Yeah.
We are happy too that we could beat you. The AI could beat the game. I think that we have a very interesting question here by Marcus. He is asking, what are some of the most interesting uses of reinforcement learning? And I put some words from me here. is that what do you think that is the how can I say in the next years when we will see where we will see reinforcement learning? So where do you think we can see this, and which kind of industry and which kind of problem will be solved in a very better way using reinforcement learning in the next years?
Yes, of course. Well, the starting point for this reasoning is, the fact that the reinforcement learning allows you to create an agent that is able to take optimal decisions. So it's an agent that is able to behave optimally in a given environment, so given a specific task. Now, this is something that can be leveraged at different levels. For example, I know for sure there are industries looking at reinforcement learning for stock trading, or in general for trading in the trading market, for stocks as well as for commodities, many different applications. And this is one thing in the advertising domain, because sometimes it's hard to select and show the user a good advertise. And now it's good advertising. Now selecting the one that optimize the click-through rate is a typical framing of a problem. So again, in advertising, of course, also in the domain of video games, you imagine that you have you want to test your game from the start to the end, and you don't want to put people in order to do that. So you can do the very same thing I did. You can train an algorithm, basically just let it play all along and go from the start to the end in order to test your game out, to find out bugs and this kind of stuff. Additional applications are, train an algorithm on a past game, so with the human data on it, and then deploy it on a new game, an unseen game from the audience, in order to try to identify patterns that people will leverage on that specific new game before it is out in the audience. So, but also, autonomous guidance in some sense, in both, maybe not vehicles, maybe more in a controlled environments. Well, it's definitely it's gonna be something to look for, because the great part is that sometimes as it happened for Go, well, these techniques are able to discover optimal strategy that are, strategies that are not known at humans, and so in this sense they may be, leveraged to exploit these strategies to obtain a very high reward. So they can also cooperate. It can be, the problem can be framed in the so-called multi-agent problem, and so you can coordinate, as for example OpenAI 5 was doing, coordinate multiple agents to achieve the same goal together. And so definitely, swarms of drones. There are a very huge number of things. Now, the key point is, before being able to do that, reinforcement learning, and in particular deep reinforcement learning, needs to improve, because the sample complexity is something that is still a huge problem to overcome. And so when you deal with huge action spaces, with huge observation spaces, we do need to improve the effectiveness, and the efficiency in this specific regard. So definitely still a breakthrough needs to happen, but we are in the right path, and also it's very, very promising.
Oh, really cool, really cool. I have another question for you. I think that seeing DIAMBRA right now, we would like to know what's your plan for the future, and what new game is, what do you think, and what are your next projects here?
Yeah. Thank you for the question. And, I'm really happy when I can talk about DIAMBRA, because it's something, First of all, maybe I can shift here. It's something that we are building with a lot of passion, because it merges, video games, super cool technology for reinforcement learning, and also entertainment. Because, it's hard for me to not getting excited when I see these kind of outcomes, as you saw today. It wasn't the first time I was watching the game played by the AI, and also it was not the first time I saw it finishing the game. But it's, for me, it's still, even though I coded it, even though I know every line of it, it's still some kind of magic, seeing how we are able to learn stuff so well. And in DIAMBRA, what we try to merge is this cool technology with video games and entertainment. So it's the entire set of these things. And well, next steps. First of all, as you can see in the website, we at the moment we have 4 games that we are showing to the public, and these are the 4 games we already have. Of course, we use them in different modes. You just saw what we called AI versus com. Okay, so the AI facing the standard computer. But of course, we already have available, we already experimented with the AI versus AI mode, where, and I think, I'm still not sure, it's not official, but I'm almost sure that the next tournament is gonna be in the AI versus AI mode, meaning that all participants, they will submit their agent, and their agent will be facing other agents. So in a tournament in this way. And of course, there is also the AI versus human mode. Our goal would be to train an AI that is strong enough to be at the human level on these games, and this is gonna be pretty exciting. Now we are already moving on that direction. And apart from, we will interface many more games, and we're gonna release them soon. And for now, we are moving on this vertical, so the fighting games for now, because of many different reasons. Also because the problem is, in terms of observation and action spaces, is smaller, and so everyone can access it. Now we will give time to the hardware to grow, thanks to the Moore law, and then we will also add additional games. For now, we are gonna stick with them, and we are gonna have a lot of more retro gaming here, and then we are already moving our steps towards modern games, because we cannot wait the day in which we will provide modern games in the very same fashion. And I'm really excited. This is on our roadmap, and we are really working hard on it. Soon we are gonna also release a platform where everyone will be able to register and take part in these competitions against other guys, or maybe at his own pace, training his algorithm and letting it face the game, as I did today, in order to learn this stuff by playing it. This is something amazing. You cannot imagine how much I learned just to, with the goal of finishing these games with reinforcement learning. Well, I managed to master a lot of cool libraries in this domain, and it's definitely very, very, a perfect way to learn machine learning in general and reinforcement learning in particular. Yes.
Oh, really cool. We have a question here for Chris that I think it's really interesting. Actually, we have 2 questions, one from Mariana and one for Chris. Mariana asked if how many people participate in your AI tournament, so we are really interested in that.
Yes.
And Chris asked if your AI always win.
Okay, so first of all, this was the very, very first tournament, and we needed it like a beta test for the entire environment, because we needed to let people install it in their own machines, submissions, mechanics, needed to be tested. So we had about 60 participants in it. That is a huge number, I think. And we also had, as you can see here, three people, these three guys will take part in the final event. So they qualified for the final event that is going to take place in 2 days on Wednesday. And as you can see, one of them was able to reach a very, very high score. And it's very, I believe it's super cool, the fact that this environment was coming out of nowhere early this year, and there are already people that are able to use it to train good RL algorithms on it, and we will make sure that this environment will grow in time, and more people will come into it, and start playing around with it.
Oh, really cool. I think that we are on time now, so I would like to thank you, Alessandro. It was a pleasure to have you here on our meetup. It was really, really cool and a really interesting talk. So we are very happy to have you here. And to everyone that is watching us, you can contact us at Datarisk, and you can contact Alessandro, because it's really good to keep in touch in this area and see things happening. So thank you very much for participating.
Of course. Thank you very much, Bruno, and you all team at Datarisk. It was a pleasure for me to get in touch with you, know you, and having this opportunity to present what we are doing with reinforcement learning. And yeah, thank you also for what you said. I relaunched the invite. Now, everyone who was interested in this stuff, of course, you can connect with me on LinkedIn. It's pretty easy to find me, and also join the Discord server, the DIAMBRA Discord server. It's a great place for RL, and a place to talk, to discuss these things. It's definitely worth it. So thank you again, Bruno. It was a real pleasure for me to be here.
Thank you. Bye bye.